In this lesson, we're going to learn about Euler diagrams. Now, I mentioned Euler diagrams earlier when we were talking about Venn diagrams. Well, Euler diagrams actually preceded Venn diagrams, and Euler was before Venn. But Euler diagrams are much like Venn diagrams, except Euler diagrams, we can put objects in more than one place. If you recall, in Venn diagrams, we can only put something in one place. So we can use Euler diagrams to describe relationships about all, some, or none. The relationship with the word all will always be one set inside another set. So in this case, if we look at this, we see all cats are animals. So we see the little cats circle inside the animal circle. And this means that cats are a subset of animals. And there it's clear because the cats are inside the circle with the animals. In example number 1, we're going to draw the diagram to show that all birds can fly. So let's see. Well, which is a subset of which? Are birds a subset of flying things, or are flying things a subset of birds? Well, there are things that fly that aren't birds, like bats. So all birds do fly. Well, there's some that don't, but we'll discuss about that issue later. Let's assume that all birds do fly. We can say that all birds can fly, and birds are a subset of flying things. So that means we could write it like this, where we have flying things, and then birds are the circle inside of flying things, or a subset of flying things. Similarly, for example number 2, we could draw an Euler diagram to show that all squares are rectangles, all rectangles are quadrilaterals, have 4 sides. So, of course, the squares are the most specific, since squares are a subset of rectangles, and rectangles are more specific than quadrilaterals, since rectangles are a special kind of quadrilateral. So all squares are rectangles, so therefore we can write our Euler diagram in such a way that we have squares, which is the most specific type of quadrilateral, which is within rectangles, which is a specific kind of rectangle, and then rectangles, which are a specific kind of quadrilateral. In example number 3, how would you use Euler diagrams to represent some animals have 4 legs? Well, some animals have 2 legs like us. Let's look for some animals that have 4 legs, but as you can see, this kitty cat has 4 legs, but the way he or she is dancing, you begin to wonder. But animals intersect things with 4 legs, and of course there are animals that have 4 legs. We can represent it as things with 4 legs, animals, and then of course there are animals with no legs like snakes, which are animals. And then there are things with 4 legs like tables that are not animals. So animals with 4 legs, well, that would be cats, dogs, and other animals with 4 legs. Euler diagrams can also represent no or none relationships. And that's a relationship will always be one set separate from another set, and there's no overlap. So, for example, no cats are dogs. There's no such thing as dats, folks. This means that there are no objects in the intersection, nothing here, between cats and dogs. The intersection of cats and dogs is the null set, meaning there's nothing here. There's no overlap. So the intersection between cats and dogs is empty. Let's look at example number 4. And how would we use Euler diagrams to represent no fish are purple? And do you think that this statement is true in real life? Well, of course, if you think it's true and that no fish are purple, then the intersection is just the null set. There is no set or intersection set. So the fish intersect purple things is 0 or the empty set. But this is not always true, just like I mentioned earlier, or I was about to mention about the birds. Yes, ostriches are birds, but to my knowledge, I don't think they fly. It turns out that this is not true either for purple fish. In the picture here at the right is called a purple parrotfish. There are fish that are purple. You would draw it with the intersection. But the issue that comes up here, for example, with the birds or the purple fish, is the idea of bringing in external knowledge. And so this is what happens when we have combining all, some, and none statements for a logical argument. So here we go. How would we represent all cats are furry and some cats are pets in one picture? We can have two different situations. And either of these pictures would be correct, because here we have the first picture shows that some pets are not furry, and the second picture shows that all pets are furry. Without bringing outside knowledge, we don't know which picture is correct, so we should draw both of them, because we don't know whether or not we're going to talk about the purple parrotfish or the ostrich. So again, we have to be careful of outside knowledge. So if we are allowed to bring outside knowledge, we know that there are pets that are not furry, pet fish, for example. We also know that there is the statement all cats are furry isn't actually true either. For example, the Sphinx is considered a hairless cat. So when we're doing these diagrams, we do not want to bring in outside knowledge unless one is explicitly asked to determine the relationship about things you know about. In example number 5, we're going to draw a picture showing the logical statement, all cats are furry, all furry things are cute, and some cute things are birds. So the first statement is all cats are furry. This means cats go inside furry things. The second statement is all furry things are cute. This means furry things goes inside cute things. So let's see if we can think of it that way. In example 5, we need to add some statement. So some cute things are birds, which tells us that birds are cute things that must overlap. So here we have birds, we have cute things, we have furry things, we have cats. And here we have the same thing, cats, cute things, furry things, and cats. But birds can be, well, they're cute things, but would we consider birds to be also furry things? Are feathers considered furry? So these are possible diagrams that you can draw for the birds. Thank you very much. I hope you enjoyed this video. Be well, take care, and goodbye for now.